Hi everybody, Amin's here. So, in this session, I want to talk about scalars and vectors. What are those and what are the differences between them? So, this is potentially a very important session that we're having because from now on, every quantity in physics that you see, it's going to be either a scalar or vectors. If you decide to go to more advanced, stages of physics, you will see other types of quantities such as tensors, but we're not worried about them right now. So let's focus on scalars and vectors for this session. All right, so let's jump to the next slide here. Definition of a scalar. It's basically a piece of information of a physical system that is direction insensitive. In other words, when you tell me about that quantity of the system, I do not need to know the direction or anything about the direction of that quantity. It has nothing to do with direction, basically. For example, temperature. If I ask you, what is the temperature of your room? And you tell me it's 70 degrees Fahrenheit. That's a complete piece of information, and I don't need to know any direction about it. It has nothing to do with direction. The same is true about pressure and power. So if you buy a super duper car and I ask you how powerful the car is, you tell me it's like 400 horsepower, and that's all I need to know about it. And that's a full piece of information about the power of the car. That is, of course, not true about some other quantities. For example, vectors that we just talked about in the first slide. So vectors, like scalars, are a piece of information about a physical system, but they are direction sensitive. For example, force. When you apply force to an object, right, not only you need to know the strength of that force that you're applying to that object, you also need to know the direction of that force. And together, the strength or the magnitude of the force and the direction gives you a full understanding of force. The same is true about acceleration, right? When you press the gas pedal in your car, you feel a force, on your back, and you feel some acceleration. And the direction of the acceleration is basically the direction of, the car, the direction of which the car is going. And same is true about velocity, right? If I tell you a bullet is, moving like 100 meters per second, then you do not have full information about where the bullet is going because you don't know what the velocity is or what the direction of the velocity is. The same is about like wind. When when you read or hear on the Weather Channel that the wind is blowing like 30 miles an hour. Yes, that's still an important chunk of information about the wind, but it's not full. It's not fully defined. And then if you read further, you'll find out that the wind is blowing from east to west or north to south or whatever. So these two pieces of information make up the information of vectors, the quantity of the magnitude of the vector and the direction of the vector. All right, so to make a little more sense of this nonsense, let's take a look at this website here. This is fet.colorado.edu. They have a bunch of really cool simulations in this website that you can play with. Among one of the newer ones, they have the projectile motion, and if I run it, let's go to vectors. Let me move myself to the other side of the screen. We see a cannon. And by the way, you can actually change the height of the cannon. Obviously, the cannon is mounted on the top of a stage. And you can change the angle of this cannon. So, this is a physics problem, right? If I ask you, when I shoot the cannon, when do you think the cannonball is going to hit the ground? Where is the impact point, basically? And I tell you the initial speed of the cannonball, which is 18 meters per second. Do you think you will be able to answer the question? I'm gonna give you a second, but the answer is no, because you know the speed, you know the initial speed, but you do not know the direction of the cannon, right? So let's keep the speed of the cannonball constant, shoot it. Oh man, actually, that was pretty close. Ooh, nice. So while I'm keeping the speed constant, I'm going to change the direction of the cannon and shoot it again. And as you can see, the impact point changes basically. So here in this problem, not only you need to know the initial speed of the cannonball, you also need to know its direction, right? And therefore, velocity, of the cannon, if you know the velocity of the cannonball, you should be able to predict where the impact point is, given that you know the height of the stage, right? Because say, if I change the height of the stage, and let's see which of these angles we were at, 65 degrees, right? So if I increase the height here, obviously we are going to hit a different point. That was pretty close, but it actually changed. Anyways, so given a constant height, right? Let's go back to 6 meters, and I believe it was 6. Let's give it a shot. Oh yeah, it was. All right. Okay, so given a constant height of the, constant height for the cannon, you need to know both the initial speed of the cannonball and the direction. And together, the initial speed and the direction make up the vector of the cannonball, of the speed, of the velocity of the cannonball. All right, so let's, just make sure that we understand all the terminology here. Speed, we, in general terms, we use as a scalar, which basically just tells you about the magnitude of the velocity of the cannonball, right? And also we have the direction of the cannonball, right? So the speed of the cannonball and the direction of the cannonball, they make up the velocity of the cannonball, which is a vector. All right, cool. Let's see if we can actually hit this sucker here. Let's go to 70 degrees, and I'm going to reduce the speed to 16. Oh man, what am I doing? Oh God, I am actually making, oh man, I'm not thinking. I am not thinking. So actually, I want to go to this angle here and shoot. There we go. That was pretty close. And let's try 17. Whoa. Yay. All right, we got it. And just out of curiosity, I want to see what happens if we shoot this person. And let's see what we can shoot it with. Oh boy. We only have the cannonball choice. That is weird. All right. Anyways, cannonball will work. Let's shoot him. Oh man, that's close. One more. All right, so basically you can drop the pants of the poor guy by shooting him with a cannon. That's pretty brutal. All right, so with this, I want to end this session and, keep studying, keep up the good work, and see you next time.